All right, so the next video we have is section 4.5, which is isosceles, equilateral, and right triangles. So this is actually a pretty simple section, so I thought it'd be a good one for you guys to do at home today. So it says use a piece of patty paper and a ruler to construct an isosceles triangle. So I have half the class trying a obtuse isosceles and half the class trying an acute isosceles. Let me draw examples of both. I'm trying to draw it nicely because I don't have my patty paper. Oops, let me make it a little bit smaller. Okay, so my goal here was to make it so that both these sides, so this side was the same as that, and this side was the same as that. So imagine you have a piece of patty paper, and you fold this side over on top of the other side, so that kind of see-through paper that we have. The fold line would be directly in the middle. What this does is it creates two triangles where we have a right angle down here, and these two angles end up being exactly on top of each other. So we can get that these two triangles are exactly congruent, okay? So if we had congruent sides originally, these angles down here are also the same, okay? And the same idea for this, if we fold it over directly on top, these two angles will match up perfectly on top of each other. So this is called the base angles theorem. So if we have sides that are congruent, we can say their opposite angles are also congruent. So the base angles of an isosceles triangle are the sides across from, the angles across from the congruent sides. And then the vertex angle is up here. So this is the angle between the congruent sides. Okay. All right, and you can have isosceles triangles that are drawn on their side as well, so don't always assume the vertex angle is at the top. So if these are our base angles, then this would be the vertex angle, and these two sides would be congruent. All right, so the base angles theorem. So it says if two sides of a triangle are congruent, then the angles opposite them are congruent. And then the converse goes the other way. So it says if the angles are congruent, then the two sides are congruent. Okay, so we're going to use that a lot. And a lot of times you're going to have these, complicated geometry sketches, and you have to figure out what X, Y, Z, W, all of those things are. And you're going to have to draw those markings in. You're going to have to know that they're congruent. Okay, so it says use the diagram of ABC to prove the base angles theorem. So we'll kind of quickly go through this. So it says given that AB is congruent to AC, so we have those markings in, and AD bisects angle BAC, prove that B is congruent to angle C. So we're going to have AB is congruent to AC, AD bisects BAC. That was given to us. The definition of an angle bisector creates these markings that I drew in. So we're going to write that angle BAD is congruent to angle CAD. The reflexive property, or same segment, is going to be that AD is congruent to itself. And then side angle side says that triangle BAD is congruent to triangle CAD. So the reason, so now that we have congruent triangles, so this triangle perfectly matches up with this triangle right here, is something that we learned about in the previous section, which we're actually going to do tomorrow in class, and it's called Cpctc. So this stands for corresponding parts of congruent triangles are congruent. So basically, if we get that two triangles are perfectly on top of each other, they're perfectly the same size, then we can say all three angle pairs are congruent, and all three side pairs are congruent. Okay, so it says using the base angles theorem, we can draw in several congruence marks in the diagram on the right. Using its converse, we can draw in several congruence marks in the diagram on the right as well. So if we have, an equilateral triangle, well, that means that all of these angles are then congruent, because we could first treat these two as our isosceles, and we could say these bases are the same. Or we could have these two being the isosceles, and then these two angles are the same. So basically, you get all the angles have to be the same in an equilateral triangle. And when all the angles are the same, then all the sides are the same. So same idea with that. So sometimes we're going to talk about corollaries. I think I misspelled this. I think it's IES. These are statements that can easily be proven using a theorem or a definition. So a corollary is something that kind of follows. It's like, oh yeah, obviously this is true because we had this other theorem that said this first thing was true. So it says if a triangle is equilateral, then it is equiangular. And the other one is if a triangle is equiangular, then it's equilateral. So we just showed why that's true. Okay, so these are kind of the complicated drawings that I was talking about. Starts out pretty easy. So it says find the value of the variables. So we have markings. So if I have these two markings in, it means I have an isosceles triangle. So that means that this angle and this angle have to be the same. So we put a 50 there. So then we can find x because x plus 50 has to equal 180 by the triangle sum theorem. So we get x plus 100 equals 180. So x is equal to 80. And the same thing on the right side of the triangle. So on the right side of the picture. So if I have this mark and this mark, then I can say these two angles are the same. Well, that means that y added to 100 equals 180 because these two angles had to be the same. It had to be another y. So 2y is equal to 80, so y is equal to 40 then. Okay, so that's what I was saying. You're going to have to just know that every time you see, these two marks, that means these two angles are the same. We're going to use that a ton in geometry. So same idea here. So I'm going to have a y there. So 110 added to y has to equal 180 because these are what we call a linear pair, right? So we have the 110 and we have y, they have to make 180. So we get y has to be 70. So then we're like, okay, well in this triangle we have 70 and that means this is also 70. So we have 70 plus x has to equal 180. So 140 plus x equals 180. So x then has to be 40. Okay, so same idea here. Now we have 44 and 44, so those are congruent. So because of that, these two are the same. So y immediately is equal to 7. The next one is 44 plus x. So as I go around my circle, or my triangle, I have 44 plus x equals 180. So I get 88 plus x equals 180. So if I subtract 88, I'm going to have 92 left. So 92. All right, let's try some harder ones. So this one I have 60, 60, and then y. Well, that means that y would also have to be 60 because this ends up being an equilateral triangle, right? So you might have jumped right to that without doing any of this work. So we get y equals 60. And now it tells us our perimeter is 54. Well, if we have an equilateral triangle, remember, that means that all three sides are the same, right? So equiangular means it's equilateral. So we're going to have 4x plus 4x plus 4x. Like all three of these sides have to be 4x then. And they add up to be 54. So we have 12x equals 54. So x equals whatever 54 divided by 12 is. So we can reduce by, well, 2, so 27 over 6, and then by 3, so 9 over 2. So you could have 9 over 2, or if you found a decimal, you can say 4.5. All right, so number 5, same idea. So I have this marking and I have this marking, so I can say angle y and the one across from it, or on the other side, are congruent, so these two angles are the same. And if I have 60 right here, couldn't I write 120 in here? So I'm going to have 120 added to y plus y. So I'm going to write 2y equals 180. So I get y is equal to 30. And then same idea over here. So I have these two markings are the same. So that means that this is 60. Whoops. So we're going to have 60 added to 60 added to x equals 180. So x ends up being 60 as well. So 120, we subtract it over. So we have an equilateral triangle on that side. All right, so same idea on this one. So we're going to have 58 because we have the two markings that say we have an isosceles triangle. So we have 58 added to 58 added to x equals 180. So that's 116 plus x equals 180. So when we subtract, we get 64. And then it looks like we have, so this is 64 here. What do we have here? So we know these two are the same. So if we have a right triangle and we have these two markings are the same, that means that this angle, which I'll call Z and Z, those two angles have to be the same. So if I have Z plus 90 equals 180, these Z values will end up being 45. So this angle right in here is 45. This angle right in here is 45. Okay, so it's getting a little snug in here. So we have basically on this side right here, we had 3 sections. So we have a section here, and we had 45, and we had 64, okay? We need to find y. So we do that by saying y added to 45 added 64, kind of like a linear pair, but there's 3 angles there. They have to add up to be 180 because they make this whole line shape like going across here. So we have 180 degrees there. So we add them together, so we have 109. So y plus 109 equals 180, and we subtract, so we get y is equal to 71. That was a tricky one. I told you they get kind of hard. All right, so same idea on this next one. So we have n, and we have 90. So what are these two now? Think about it. We have 90 plus n equals 180. So these are both 45 degrees. And then we have 50 up there. So this one I think is going to take a little bit of a trick. Okay, because we don't know, like we could do 45 plus m, right? Being this whole angle here. So we could say 45 plus m, and then this other side could be 45 plus m, plus 50 equals 180. We could do that because we have this angle, and this angle. And we could solve it out. So we have 140 plus 2m equals 180. So 2m equals 40. So m is equal to 20. So that's one way of doing this problem. But sometimes if you see some symmetry involved, it makes your life a little bit easier. So let me write other way. And I'm seeing a lot of symmetry in this problem because I know this side is the same as this side. So I'm going to cut it right down the middle. So think about your patty paper. Wouldn't this work? Couldn't we just cut it right down the middle? Then these two angles end up being 25 and 25. And this angle in here would be 45, but I don't think we really need that because we have our 25 and our 25. And this would be 90. So think about our patty paper, why that would be true. And then we can get this whole angle. So we can say, oh, that whole angle then, if I had 25 and 90, then I'm going to need how much left? I would need 65 left. And then you can subtract out that 45 that you had before to get just the m. So that would be another way of doing it. So you can say 25 added to 90 added to, we'll call this whole thing z, equals 180. So we end up getting z is a total of 65. But z, kind of hard to see in my drawing, was this whole m plus n. So if we have 65 is equal to 20 plus, or not 20, we're trying to find m, was equal to m plus n, which we found right away was 45, then m has to be 20. Okay, so that's another way of doing this. And part of being a good geometry student is sometimes you look at a picture and you just kind of play around with it. And you could find lots of different ways to get measurements. And that's why I think some people are very successful in things like the SAT because they have these logic skills. They can kind of work through the problem without having someone tell them to memorize every single formula, right? You have to think about different ways to solve the problem. All right, so the next one, kind of same idea. So we have 30 outside now. We could split it down the middle if you want, or you could find it another way. So let's talk about this whole angle here and this whole angle here. Okay, so we know that we would have, I'm wondering if this one, I think this one's actually not possible. Let's try it though. I think I am missing one bit of information on this one, so I'm going to skip it. Okay, so far we have learned 4 ways to prove triangles are congruent. So, like we talked about, we have side, 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 angle, side, angle, side, angle, and angle, angle, side. So you have to know those. So memorize those different sets of letters. There's one more. The last one is hypotenuse leg. So what this means is if I have the hypotenuse and I have a leg, this is a form of angle, side, side, right? That's spelling out the bad word. Okay, so this is a form of side-side angle that works. And it's a very specific form. We have to have the right angle because if I have, 8 and 10, I can find that missing side by using the Pythagorean theorem. Then it really turns into a side-side-side problem. Okay, so that's basically what it's saying. So for number 1, it says, is it possible to say the following triangles are congruent? Explain. So it looks like it's going to be set up as an angle, angle, side, but this one doesn't have angle, angle, side. It has side, side, angle. But what did we learn today? We learned that when we have these 2 marks here, we can say these 2 are the same. And when we have these 2 marks here, we can say the angles are the same. So it's actually works out to be an angle, angle, side. Okay. So you can go around angle, angle, side. All right, this next one looks like it's going to be a side, angle, side, but if you pay close attention to this other one, this is in the wrong location. It should be over here, right? So this one's actually nothing. It doesn't work, so no, you cannot prove they're congruent. The next one is our hypotenuse leg, because we have the hypotenuse and we have a leg. And the last one, it looks like angle, side, angle. Let's see if we have angle, side, angle over here. Well, we definitely know these angles are the same as each other, but are they the same as these ones? Not necessarily, right? So really, if you think about some counterexamples, let's think about some counterexamples. What if I had the original markings and I had an isosceles triangle and I had this was 70 and 70 and then 10, okay? I could still have the 10 on the bottom, but these could be like 80 and 80, right? That still makes these markings the same. Oops, I guess I need 2 marks for those. Those still have the same markings, but those are totally different triangles, okay? So be really careful and don't assume that certain angles are congruent to angles in the other triangle. All right, so let me stop there.